We are pulling directly from a really fascinating 2024 study today, published in the Journal of Sports Science and Medicine.
Yeah, that's a great one.
It really is. The article is titled Post-Activation Performance Enhancement, Possible Contributing Factors, and it's authored by Josef Fischer and Florian K. Paternoster.
Right.
And we're starting with this specific citation because, well, usually when we talk about a medical diagnosis or, a physiological measurement, there's this expectation of clinical precision.
Oh, absolutely. Like you break your arm, the x-ray shows that jagged white line, and the doctor just points to a very specific, undeniable mechanical failure.
Exactly. It's visible, it's binary, and honestly, it's comforting. Medical science loves a neat categorization.
It really does. But the moment you step into the world of high-performance sports science, that diagnostic x-ray machine just sort of seems to break down.
Yeah, the landscape gets remarkably murky. So our mission for this deep dive is to investigate how athletes attempt to use intensely heavy muscle contractions to basically hack their bodies for short-term performance boosts.
Which is something athletes have been trying to do for decades.
Right. But more importantly, we're going to use Fischer and Paternoster's research to untangle a massive scientific debate between two highly contested physiological phenomena. Things that researchers and coaches have literally been mistakenly treating as the exact same thing for years.
And this matters immensely for you listening right now. I mean, whether you're a seasoned athlete trying to optimize your workout routine, or someone who simply hits the gym a few days a week, or, just a person fascinated by the incredible biomechanics of the human body.
Totally.
Understanding what is actually happening inside your muscle fibers versus what is happening in your brain, it changes everything about how we view physical preparation.
It really does.
We're talking about designing an experiment that isolates the literal electrical signals of your central nervous system from the raw mechanical reality of your muscle tissue.
Okay, let's unpack this. The baseline of this great muscle mix-up starts with the original phenomena, right? PAP, which stands for post-activation potentiation.
Correct. And looking at this with strict physiological clarity, PAP is an immediate localized increase in a muscle's twitch torque following a voluntary contraction.
So basically, you lift something incredibly heavy, and the moment you put it down, that specific muscle is primed to fire harder.
Exactly. But the mechanism driving this localized boost is entirely peripheral.
Meaning it's not the brain.
Right. It happens right there inside the muscle fiber itself, completely independent of the brain's signaling. It fundamentally comes down to the phosphorylation of the regulatory myosin light chain.
Okay, let's translate that microscopic architecture for a moment. Deep down in the muscle fibers, you have these tiny protein filaments called actin and myosin, right?
Yeah, and they essentially slide past each other to create any muscle contraction.
Right, and the myosin has these microscopic heads that reach out, bind to the actin filaments, and physically pull them.
Exactly. So when you execute a heavy conditioning contraction like a near maximal isometric hold, a massive amount of calcium suddenly floods the muscle cell.
And that flood does what? Exactly.
Well, this calcium triggers a chemical reaction that attaches a phosphate group to the myosin. That addition of the phosphate group is the phosphorylation, and it physically alters the structural geometry of the muscle cell.
Oh, wow. So it changes the shape.
Yeah, it moves that myosin head physically closer to the actin binding sites.
So it's like hovering your finger just a millimeter above a keyboard key rather than holding your hand a foot in the air.
That's a perfect analogy. The next time you need to strike that key, you're already right there. It geometrically increases the probability of those cross bridges forming.
Meaning the muscle can contract with significantly more force and much faster.
Right. The muscle is now structurally hypersensitive to calcium. But, and this is crucial, true, PAP has a severe limitation.
The timeline.
Exactly. It is incredibly short-lived. The mechanical potentiation peaks the very moment the heavy lift ends.
Huh.
From there, it has a half-life of roughly 28 seconds.
Wait, 28 seconds? That is incredibly fast.
Yeah. Within 3 to 12 minutes, the structural advantage vanishes entirely, back to zero.
Which introduces the imposter term into the scientific literature. PUPE, or Post-Activation Performance Enhancement.
Right, be imposter.
PPE describes a voluntary performance increase, like an athlete suddenly being able to jump noticeably higher or sprint noticeably faster. But this phenomenon allegedly happens 5 to 10 minutes after a heavy conditioning contraction.
And that glaring contradiction in the timeline is exactly what created this entire scientific mess.
Because the timelines just don't match up. So if PP is like a sudden, localized lightning strike of pure physiological force, is PP more like a slow-burning fire that requires the whole body to coordinate?
That's one way to look at how people perceived it, yeah. Coaches observed that heavy lifting sometimes made subsequent athletic movements better.
But I have to push back here. How could scientists confuse the two if their timelines literally do not overlap? I mean, proposing that a mechanism with a 28-second half-life is responsible for a performance boost peaking 10 minutes later, it defies basic logic.
It does. But because PP, that microscopic myosin phosphorylation, was literally the only biological mechanism they had a label for at the time, the community just assumed that this structural change must be causing the delayed athletic boost.
Even though the first phenomenon is effectively dead by the time the second one is supposedly peaking?
What's fascinating here is that once modern researchers realized that PP occurs exactly when true PP is fading away, they had to hypothesize entirely different mechanisms to explain the delayed boost.
They realized it couldn't be the protein structures.
Right. They theorized that PP must be driven by broader physiological changes.
And one of those theories is just basic thermodynamics, right? Increased muscle temperature.
Exactly. When a muscle works heavily, it generates metabolic heat. This heat warms up the sarcoplasm, which is the fluid inside the muscle fiber.
Okay, so think of the sarcoplasm like honey. Cold honey is thick, right? Highly viscous, causing a lot of friction.
Yeah, and as the muscle warms up, the viscosity of that fluid drops. It becomes thinner. This lack of friction allows the myosin ATPase enzyme, which is the enzyme breaking down energy for contractions, to cycle much faster.
Oh, that makes sense.
And the fluid content inside the fiber also shifts, decreasing ionic strength, which allows more force to be generated per individual crossbridge.
So that's the temperature theory. Then you have the most debated theory of all, neural factors.
Right, a brain's involvement.
This is the idea that the central nervous system, meaning the brain and the spinal cord, essentially gets more excited and becomes more efficient at recruiting motor units after a heavy lift. The brain just gets temporarily better at talking to the muscles.
But testing these theories has been notoriously difficult. I mean, temperature changes, fluid dynamics, and neural drive, they all happen simultaneously when a human being works out.
Yeah, you can't just isolate one in a regular gym session.
Exactly. Disentangling which of those variables is actually responsible for the delayed PP boost has been nearly impossible in a standard gym setting.
Because proving that those neural factors don't exist requires a near impossible variable to control. You have to somehow sever the brain's connection to the muscle during a heavy lift to see if the muscle still gets the delayed boost on its own.
Which brings us to the study.
Yeah, how did Fischer and Paternoster actually pull that off?
Well, they engineered an incredibly rigorous methodology. They recruited 13 strength-trained men with an average age of 26 and a half.
So guys in their prime who know how to lift.
Right. These were individuals with at least 3 years of consistent lifting experience, ensuring their central nervous systems were already highly adapted to generating maximum force.
You don't want beginners whose brains are just learning the movement.
Exactly. So they strapped these participants into a highly sensitive piece of lab equipment called an Isometric 2000 dynamometer.
And just to clarify for everyone listening, this isn't just a standard weight machine you'd see at your local gym.
No, not at all.
It is an isokinetic dynamometer that locks the participant in, fixing their hip and knee angles completely, so they are performing isometric knee extensions at exactly an 80-degree angle.
Which is crucial. By isolating the movement entirely to the quadriceps, without any change in muscle length, the machine measures raw torque down to the Newton meter. It removes all the unstable variables of, say, a free weight squat.
So the biomechanics are locked down.
Yep. And they ran the participants through 3 distinct protocols on different days.
Okay, let's break these down.
The first protocol was the baseline PAP trial. To test that true localized lightning strike of myosin phosphorylation, they bypassed voluntary movement entirely.
Meaning the guys weren't trying to push.
Right. They used supramaximal electrical twitches, sending a current into the muscle that was 1.5 times the maximum needed to recruit every single fiber.
Wow.
Yeah, this established the absolute baseline of what the muscle tissue could do mechanically without the brain.
Okay, so that's the baseline. The second protocol was the PAPE voluntary trial, or PAPV. And this one basically replicates a standard athletic warm-up setup.
Exactly. The participant voluntarily pushes against the fixed arm of the machine at 80% of their absolute maximum effort, holding it for 6 seconds and completing 3 sets with a 2-minute break.
So this is the heavy conditioning contraction that coaches claim will make you jump higher 10 minutes later.
Right. And then the third protocol is where the researchers achieve that near impossible variable control, the PAPE electrical trial, or PAPE.
Okay, here we go.
The participants were subjected to the exact same conditioning contraction, 80% of their maximum force, for 3 sets of 6 seconds. However, they did not voluntarily push.
Wait, they literally zapped these guys' legs with 400 volts just to see if their brains were the ones doing the heavy lifting during PAPE?
They did. The researchers completely bypassed the central nervous system by sending a 400-volt electrical stimulation directly into the quadriceps, forcing the muscle to contract to that exact 80% threshold.
Okay, I have to challenge this setup. Because if you zap a human thigh with 400 volts to violently force an 80% max contraction, doesn't that massive electrical current inherently alter the localized cellular environment?
It's a valid concern.
I mean, wouldn't the shock itself generate artificial heat or disrupt the sarcoplasm, basically ruining the delicate physiological baseline they were trying to observe?
It is a vital question because altering the local environment would totally invalidate the data. However, the researchers specifically utilized wide surface electrodes and carefully calibrated pulse durations that mimic the natural action potentials of human motor neurons.
So it feels to the muscle like a brain signal.
Exactly. The electrical current dictates the signal to contract, but the actual mechanical work and the metabolic heat generated by the sliding actin and myosin filaments remain identical to a voluntary contraction.
Oh, I see.
Yeah, by perfectly matching the duration and the 80% intensity, the metabolic byproduct in the tissue is identical. The only missing variable is the brain's intention to push.
That is brilliant.
It really is. If the central nervous system getting primed is the real cause of PAPE, you would only see a delayed performance boost after the voluntary trial.
Because only the voluntary trial involved the brain.
Right. But if the boost happened after the electrical trial, too, it would prove the effect is purely localized in the muscle tissue's fluid dynamics.
That sets up an immaculate control for the nervous system. But this is huge. They implemented one more scientific control that honestly dictates the entire outcome of this experiment, the warm-up protocol.
Yes, because increased muscle temperature is the leading competitor to the neural drive theory.
Right.
Putting athletes through a standard 20-minute heavy cycling warm-up would cause their core and muscle temperatures to skyrocket. If you want to isolate the neural signals and the pure structural mechanics, you have to take thermoregulation out of the equation entirely.
So Fischer and Paternoster utilized a strictly minimalist warm-up. The participants performed just 60 active dynamic stretches of the quadriceps.
Just leg swings, basically.
Yeah, they did 3 sets of 20 reps, simply swinging the leg out to lubricate the knee joint and prevent injury. It was specifically calibrated to be so light that it would not raise the core or local muscle temperature.
So the stage is perfectly set. The muscle is isolated from the brain using the 400-volt stimulation, and the mechanical function is isolated from the temperature variable by utilizing the minimalist warm-up.
Here's where it gets really interesting. The data reveals exactly how the body prioritizes these systems, starting with the classic PP protocol.
The lightning strike.
Exactly. Just as the microscopic structural models predict, the localized potentiation absolutely worked. 2 seconds after the heavy contraction, the peak torque of the muscle spiked by 55.6%.
Massive increase. But more importantly, the rate of torque development, or RTD, spiked as well.
And RTD is arguably the most critical metric for functional sports performance. I mean, if you are sprinting, your foot is only in contact with the ground for roughly 300 milliseconds.
You do not have time to gradually build up to your maximum strength.
No, you need a massive amount of force instantly.
And the data showed the participants' RTD jumped by an incredible 63.7%, just 2 seconds after the conditioning contraction.
That is wild.
It is. This definitively proves that the phosphorylation of the myosin light chain, that hovering finger over the key, is a very real, incredibly powerful biological feature of the human quadriceps.
Bites?
But aligning perfectly with the timeline of calcium sensitivity, by the 4-minute mark, that 60% mechanical advantage was entirely gone.
Poof.
Just gone.
Completely. The muscle had returned to its baseline resting state.
So the structural advantage fades, bringing us to the highly anticipated PP results. The researchers tested the participants' maximum voluntary force at 4 minutes, 8 minutes, and 12 minutes post-contraction.
Which is the exact window where the delayed PPE effect is supposed to arrive and elevate athletic performance.
Right, so what happened?
The data at those time intervals revealed absolute failure.
Wow. Nothing.
Nothing. At 4, 8, and 12 minutes, there was no significant improvement in peak torque or the rate of torque development. Furthermore, the researchers utilized surface electromyography, or EMG, to definitively track the neural drive.
And for those unfamiliar, EMG involves placing electrodes directly on the skin over the quadriceps, specifically the rectus femoris, vastus medialis, and vastus lateralis. These sensors detect the electrical potential generated by muscle cells when they are neurologically activated.
Exactly. So if the central nervous system was learning to recruit more motor units, or increasing the firing rate of those units, which is the very definition of the neural drive hypothesis, the amplitude of that EMG wave would spike.
The brain would be sending stronger, louder signals.
Right. But the EMG amplitudes showed absolutely no significant differences across the 4, 8, or 12-minute marks. It remained entirely flat.
Flat. Unbelievable.
It didn't matter if the initial conditioning contraction was voluntary, meaning the brain was heavily involved, or if it was the 400-volt electrical trial where the brain was completely bypassed. Neither intervention produced that magical delayed performance enhancement.
If we connect this to the bigger picture... Oh, wait, I think you usually say that.
Yeah. If we connect this to the bigger picture, the implication of this failure is profound when we look at the broader landscape of sports science. It all loops back to that 60-rep dynamic warm-up.
The leg swings.
Yes. Because the researchers deliberately prevented the participants' muscles from accumulating metabolic heat, the PPE effect never materialized.
By taking away the heat, they took away the phenomenon entirely. You go into the gym, you do a set of heavy squats, you wait 8 minutes, you jump higher, and you think your central nervous system is powerfully potentiated.
But it's not.
Right. In reality, your myosin ATPase enzymes are just operating faster because your sarcoplasm's viscosity decreased.
Yeah.
Your body temperature simply went up a degree or two.
That's all it is. The delay that athletes and coaches experience isn't some complex neurological priming. It is simply the time required for the metabolic heat generated by the heavy exercise to permeate the muscle tissue and optimize the fluid dynamics inside the fibers.
Wow.
Yeah, without the thermal shift, as this controlled study demonstrated so clearly, there is no delayed enhancement.
Tying this directly back to the mission of our deep dive, the authors sought out to untangle PAP and PAPE and to isolate the nervous system's role in delayed performance. First, they definitively proved that PAP and PAPE do not overlap in any capacity.
Not at all.
The mechanical myosin boost is dead and gone before the delayed performance window even opens. Therefore, the scientific and coaching communities must immediately stop using the terms interchangeably. They are biologically distinct events.
And second, because PAP completely failed to manifest without a proper temperature-raising warm-up, the researchers couldn't definitively analyze the neural mechanisms. I mean, you cannot analyze the origin of an effect that isn't present in the data.
Right, you can't measure a ghost.
It's exactly.
Yeah.
But by demonstrating its total absence in a temperature-controlled environment, they revealed how overwhelmingly reliant PPE is on simple thermoregulation. Science cleared the muddy waters by meticulously isolating a variable that everyone else in the gym simply took for granted.
So, what does this all mean for you? We can distill this down to a practical reality for your own physical preparation. Your muscles absolutely experience an incredible microscopic mechanical boost immediately after a heavy lift.
Real physical potentiation.
Yeah. If you require a massive surge of power, executing a heavy contraction, and immediately performing your explosive movement within a few seconds, that will leverage that myosin phosphorylation.
But you have to be fast.
Right. But if you are relying on a delayed protocol where you lift heavy, sit on a bench for 10 minutes, and expect your nervous system to magically allow you to jump higher, that is PPP, you are not hacking your neurology, you are just experiencing the basic physiological benefits of a really good sweat-inducing warm-up.
And this leaves us with a highly provocative question to consider regarding professional sports. I mean, if the true mechanical potentiation of our muscles, that legitimate 60% boost in force development, lasts for less than 3 minutes, how much of a professional athlete's elaborate delayed pregame routine is actually providing a physiological advantage?
That is a great question.
Right. If the delayed benefits are simply thermoregulation, how much of that carefully timed, complex rest period is purely a psychological placebo effect, giving the athlete the confidence they need, while their body is simply benefiting from finally being warm.
The placebo effect disguised as advanced sports science. Incredible. We highly encourage you to explore the full methodology, the surface EMG data, and the intricate biomechanical breakdowns by reading Fischer and Paternoster's complete article, Post-Activation Performance Enhancement, Possible Contributing Factors, in the Journal of Sports Science and Medicine.
It's definitely worth the read.
It absolutely is. Also, make sure you follow our channel and turn on notifications so you never miss a deep dive into the fascinating science behind how we work.